So the second part of the topic is something called dimensional analysis, which we're going to use in order to do unit conversions and kind of analyze the units in a problem so that they can help us solve the problem even if we don't know the equations. So to kind of introduce what dimensional analysis is, first I'm going to give you a quick definition and then we'll do an example to show this definition. So dimensional analysis basically means using units as if they were algebraic variables. Algebraic variables. So what does that mean? So algebraic variables are, for example, x and y when you do equations, or a and b. So you know, for example, if you have an equation that is y equals a x plus b, if you divide this by a, you probably already know from algebra class that a on top and a on the bottom cancels out. And that is because a is an algebraic variable, which means you can cancel it out. If you subtract a b here, you can cancel this plus b with the minus b. So that is what we're going to do, but with units. So we're treating units as if they were algebraic variables. So maybe this makes no sense, but I'm going to do an example to explain it. So as I was telling you in the previous video, we know that velocity is distance over time. So if we multiply time on the other side, we're going to get the equation distance is velocity times time. Not something you need to know yet, but just for this example. So suppose you're given in the problem that there is a velocity of someone's moving at 5 meters per second, and they move at that speed or at that velocity for 10 seconds, right? So you want to find the distance that they cover. So what you do here is that you multiply, you put into velocity the whole quantity, which includes the number and the unit. So you want to find distance, let's call it d so that it's shorter. And you put here 5 meters per second times 10 seconds. So this meters per second, you can put the per second below. And doing exactly the same thing as when we divided a with a and it canceled out. If we have a second on the top and a second on the bottom, these will also cancel out. So our distance would be, we multiply the numbers together, 5 times 10 gives us 50, of course, and seconds by seconds and seconds canceled each other out, so we're only left with meters. And notice that meters is actually a unit of distance, so we did it right. This works if you know the equation, and it works if you forget the equation. If you know that you were given something in meters per second and something in seconds, and you know that the distance which you're trying to find has to be in meters, you have to arrange these numbers such that the seconds from the time cancels out with the meters per second, with the part of the over second of the velocity. So that's a really useful trick, sort of, to know what if you have to multiply or if you have to divide. So it helps every time you do a calculation in physics with units. When you cancel everything out, you should be left with the units that you expect. If you're not left with those units, then you made a mistake and you can go back and check what you did. So that is like the first part, the introduction. So you can make this even more interesting. So suppose you want to convert units. As I was telling you in the previous video, there are some units which are not metric, but the US uses them a lot, and because our education system is based on the US's education system, we are faced with these units quite often. So those are feet, which are written FT, and miles mostly. Miles. MI. Remember that only M is meters. So if you put M, I'm going to think you're talking about meters instead of miles. So these are the, oh right, in inches, of course. Inches. So I'm going to give you these conversion factors. You don't need to know them. But for example, 1 inch is equal to 2.54 centimeters, right? So what if I wanted to know how many centimeters there are in 5 inches? So I'm asking how many centimeters in 5 inches. And one of the most common questions that students ask me is, Miss, do I have to divide or do I have to multiply? So the way that you can answer this yourself, if you don't see it clearly, because some people just see it and some people don't. So if you don't, you want to use dimensional analysis to check. So you're going to find centimeters and you start with 5 inches, right? 5 inches. And now you want to multiply by something, a fraction, which cancels out the inches and gives you an answer in centimeters. So what you do here is put inches on the bottom so that it cancels with inches on top. And what you want to get is centimeters. So you have to put here two numbers that mean basically 1, because if you multiply 5 by anything other than 1, you're going to be changing this value. So a number of centimeters over a number of inches has to give 1, so that this whole thing inside of the parentheses is equal to 1. So if we go back to this equation, we can put that 1 inch is equal to 2.54 centimeters, right? So if we divide 2.54 centimeters into 1 inch, we're going to get 1. So this equation keeps giving you 5 inches. But now we can cancel the inches on top with the inches on the bottom, and our answer is going to have units of centimeters. So if we do this multiplication, we're going to get an answer in centimeters. So now we have centimeters, and we just need to multiply 5 by 2.54. That is 1.27. I think you can check it in your calculator if I made a mistake. Sorry, 12.7. Yeah, you can check. I'm not sure, but that's not the point. The point is that the multiplication lets you cancel out the units to get the units that you want. So this was a simple one. We can do one that's even harder. So one conversion that you're going to have to do quite often is from kilometers per hour to miles per hour. So we have an example. So let's see how many kilometers per hour is, let's say someone is going at 10 miles per hour. And we want to know how many kilometers per hour is 10 miles per hour. So we need another conversion factor. And this one would be that there are 1.6 kilometers in 1 mile. So this is another equality or conversion factor, 1.6 kilometers per mile. Yeah, so how do we solve this? So we do exactly the same. We want to start with the number 10. So this is 10 miles per hour. And we want to multiply it by something that is equal to 1. But also that it cancels out the unit that we don't want. So hours we still want. We still want to have hours on the bottom because we're moving from miles per hour to kilometers per hour. So we're not going to do anything with that h. We want to leave it there. But we want to cancel out miles. So we need, because miles is on the top, we need a miles on the bottom to cancel out the miles on top. And what do we want to get to? To kilometers. So we put kilometers here. Right? So how many miles are in how many kilometers are in 1 mile? Because that's what the number that we have. 1 mile, so we put the 1 here in mile, is equal to 1.6 kilometers. 1.6 kilometers. So now miles cancels with miles, and whatever we get, whatever this number gives, is going to give us in kilometers per hour. So 10 times 1.6 is 16. So we're going to get 16. And the unit which we're left with is kilometers per hour, right? So maybe just by looking at this, you know that you need to multiply by kilometers, but maybe you don't. So in what case would you need to divide by 1.6 instead of multiply by 1.6 if we were doing this backwards? So make sure you pause or take notes of this, because I'm going to erase it and see what happens if instead of passing from miles per hour to kilometers per hour, we wanted to do the opposite. So let's say we still have the 10, but we want to know how many miles per hour is 10 kilometers per hour. So we start in the same way, exactly the same way, with 10 kilometers per hour. Oops, this was my other color. 10 kilometers per hour. And we want to multiply it again by something that is equal to 1 so that it doesn't change the value that we started with. So hours, we want to leave it there. We still want hours because of miles per hour and kilometer per hour, but we need something to cancel out kilometers. So now, because kilometers is on the top, we want to put kilometers on the bottom. And we need to put something on the top. What are we looking for? We're looking for miles. So now notice that they're switched. Kilometers is on the bottom and miles is on top. But now you still need to put the 1 with the miles and the 1.6 with the kilometers. So now the 1 from the miles has to go on top, and the 1.6 from the kilometers has to go on the bottom. So now that will cancel out kilometers, and we'll be left with an answer in miles per hour. And here I am going to need my calculator, because if you see, this is multiplying 10 by 1 over 1.6. So we have the number 10, and we multiply it by 1 over 1.6 in parentheses. And that gives me 6.25. So 10 kilometers per hour is 6.25 miles per hour. Right? So that is why dimensional analysis is useful. You don't have to memorize that you always divide when you're going from kilometers per hour to miles per hour, and multiply when you're going from miles per hour to kilometers per hour. No, you simply put the fraction such that the unit cancels out and you're left with the correct units, right? So, so that's an importance of dimensional analysis. And I'm going to do a final example, which is a little bit more complicated than that, just to show the extent in which dimensional analysis can be used. Okay, so this problem says the following. So Mia, who is just a girl, paints her house at a speed of 12 cubic meters per hour. So what is this in cubic centimeters per minute? Right? So now we have a mixed unit that has a squared, and we're also going to have to use this table because we're passing from meters. Oops, of course this has to be squared. From square meters to square centimeters, and from hours to minutes. So now we're going to have to do 2 at the same time. We're going to have to multiply by more than one factor, and we're going to have to square it. So bear with me. So let's see. This is just an area over time. So it's how many meters, so how many square meters she can paint per hour. Okay, so again, we start with the original number. We write that down. So we have 12 square meters per hour. So we need to convert 2 things, hours to minutes and square meters to square centimeters. And we can choose to start with whichever we prefer. So I'm going to do hours to minutes. So we need to multiply by something that cancels out the hours and gives us minutes on the bottom. So hours is on the bottom. To cancel it out, we can't put hours on the bottom again. We need to put hours on top, right? Because on top will cancel out with the one on the bottom. And we're going to minutes. So we put minutes on the bottom. So here, we need to know how many minutes are in 1 hour. So we can know that, hopefully you know that in 1 hour, there are 60 minutes. So notice that we didn't have to remember that we had to divide by 60. The 60 just came to be on the bottom of the fraction naturally by trying to cancel out the hours. Okay, so now hours has canceled with hours, and we're already at square meters per minute, but we need square centimeters per minute. So now we need to multiply, we need to cancel the meters and pass the centimeters. So meters is on the top, so we need meters on the bottom. And we need to pass the centimeters. So how many centimeters are there in a meter? So we can look at our little table and notice that centi is times 10 to the negative 2. That means 2 zeros, so that's 100. So 1 centimeter is 1/100th of a meter. That means that in 1 meter, there are how many centimeters? 100. 100 centimeters. So that would cancel out meters, but notice that we have a squared here. So it's going to cancel out one of the meters, but we need 2 meters on the bottom, 2 m's on the bottom. So we multiply again by 100 centimeters per meter. So now we have 2 m's on the bottom, 2 m's on top, and we can finally cancel the 2 m's with the m squared. You could have also squared this whole fraction because it's the same thing as multiplying by it twice. So this whole number times the 3 fractions is going to be what we put into the calculator to find out what 12 square meters per hour is in square centimeters per minute. So here we go. So we put 12 times, and we open parentheses, and we put 1/60. Close parentheses, times, open parentheses, 100/1. 100/1. Times, open parentheses, again, 100/1. Multiply all of that together, and we get 2,000. 2,000. And we look at what our unit is. So we have, on top, we have centimeters and centimeters, which is squared centimeters. And on the bottom, we have only minutes because everything else canceled out. So we have square centimeters per minute. And that's exactly what we wanted to find. So that's how we went from 12 square meters per hour multiplied by 3 fractions that each of them are equal to 1, because 1 hour is the same as 60 minutes, and 100 centimeters is the same as 1 minute. So we didn't change the value, we only changed the units. And we got that by treating units as if they were algebraic variables. So this is using dimensional analysis to solve a problem in which we need to convert units without memorizing if we need to divide or multiply by the conversion factor, and instead just multiplying always by something that cancels out the units that you need to cancel out and leaves you with the units that you need to leave.